All right, today's lesson is lesson 66, logarithms. Logarithms are inverses of your exponential functions. Okay, how do we find an inverse? Switch x and y. So, given the exponential function, y equals b to the power of x, its inverse would be x equals b to the power of y. Okay. And then now we want to solve this for y. But since y is in the exponent, we're kind of stuck. By definition, these two things are two ways of saying the same thing. So, x equals b to the power of y, and y equals log base b of x are again two ways of saying the same thing. So, y equals b to the x and y equals log base b of x are inverses. This is our logarithm. Okay, now if you look down here, now we have a graph. We are not doing graphs today, but I just gave you a graph to have a visual. Okay, you've already been doing the exponentials. You have that idea. Now, logarithms would be the inverse. It's going to switch x and y. So now we have this kind of idea. Again, this part right here, we're not really too worried about it today, but I want to go ahead and throw it out there. This is called the argument. And that argument must be positive. Well, again, if you look at your graph here, it's only defined for positive x values. X being the argument in this case. It will get manipulated. But for this case, x is the argument, but your argument must be positive. First step, we just need to be able to go back and forth between these two. Again, let's look at this. Going back to the top. Let me erase that. I got too much stuff going on. Alright. To get from your logarithm to your exponential or vice versa. Okay. The base of the log is the base of the exponential. So, the base is the base. What the logarithm equals, that is the exponent. So what your log equals is the exponent, and then the last thing being the argument of your logarithm, that's what your exponential equals. But the way I remember it, basically, is just simply the base equals the base, and again, what your log equals is the exponent. So, number one. Okay, we're not solving, there's no variable here, we're just manipulating. Let's rewrite log base 4 of 16 equals 2 in exponential form. Okay. The base of your logarithm is the base of your exponential. What the logarithm equals is the exponent. And then now this will equal your argument. So just rewriting this, we get 4 squared equals 16. Next one, same idea. The base of your logarithm is the base of your exponential. What the logarithm equals is the exponent, and it will equal the argument. And that is your answer. Number 3. Now, we are going the other direction. Given the exponential, let's write it in logarithmic form. So we would write log base 5. Does the exponential base 5 be a log base 5? Of 125 equals 3. Now again, the base of your exponential is the base of your logarithm. The the exponent is what the logarithm equals. The 125, that's your argument. Next, number 4. Log base 36 of 216 equals 3/2. And again, note, the log 216 equals 3/2 all should be at the same level. The 36 is your base, it's a subscript. Alright, now that's manipulating. Now, we move on to number 5. Now we're going to go into evaluating. Okay. For what we are doing today, let's evaluate log base 2 of 32. We're going to set it equal to x, and then we are going to manipulate it and change it from logarithmic form to exponential form. So the base of the log becomes the base of the exponential. What the logarithm equals is the exponent. And then now this equals the argument. Now at this point, we do it just like you did the exponential equations a few lessons ago. We are going to rewrite 32 with a base of 2. So 2 to what power is 32? It's 2 to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 5. Alright, now that the bases are the same, then that means the exponents must be the same, so x equals 5. Now be careful, go one step further here. This problem did not have an x in it. I made it up. So in this case, our final answer should not be x equals 5. It is just simply 5. Next problem. Well, hold on. Let's back up to this. What this problem is really saying is 2 to what power will give us 32 as an answer. That's what the logarithm means. And so by doing the algebra, we get our answer. Now that problem was actually pretty easy if you understood what it means. Next one, not so obvious. That's why we want to do the algebra. So, doing this algebra, same thing. We're going to set it equal to x, or n, or a, or whatever variable you want. It does not matter. Change it from logarithmic form to exponential form. So base 16 to the power of x will equal the argument of 8. Now this time, we cannot write 16 with the base of 8. Again, just like we did with our exponential equations, we can change both of them to a base of 2. So rewrite 16 as 2 to the 4th power, still to the power of x. Rewrite 8 as 2 cubed. Once we have one thing on the left, one thing on the right, the exponents are equal. Then solve for x. But again, go one step further, our final answer actually should not have x. It's just simply the 3/4. Alright, that was page 1. Page 2, some properties of logarithms. Okay, these you just simply need to memorize. Okay, first one, log, base b, base anything. Does not matter what the base is. If the argument is 1, the answer will always be 0. What it is really saying is b to what power will equal 1. Well, you already know anything to the power of 0 is always 1. Hence the answer is 0. Next one. If the base of your logarithm and the argument are the same thing, so log base b of b, it will always be an answer of 1. Last two, exponentials and logarithms are inverses of each other. When you do inverse operations, you always cancel each other out. So, for this one, I have an exponential within the logarithm. They both have a base b. So the log base b and the exponential base b cancel, leaving us with just x. Same applies to the next one, just the other way around. Here we have a log base b within the exponential base b. Okay, but still, your log base b, your exponential base b, they cancel, leaving us with just the answer of the argument, which in this case is x. So, next, we're going to evaluate these without doing any algebra. You should just be able to look at it and know the answer based on these 4 properties we just talked about. So, log base 5 of 5 to the 4th power, the answer is just 4. That property right there. Next one, 6 to the power of log base 6 of 2x plus 5. Once again, it's just going to be 2x plus 5. That is that property. Exponentials within the logarithms, logarithms within the exponentials. Number 9. Log base 12 of 12. The answer is simply 1. That is that property. And the last one. Log base 4 of 1 is 0. Doesn't matter what the base is, if the argument's 1, it evaluates to equal 0. All right. Next concept. Common logs. Okay, your common log is log base 10. Okay, it's just a base 10 is a very common base. That's what our number system is based on. Somewhere along the way, somebody got lazy and got rid of writing base 10 all the time, and they just kind of dropped it. But there is no such thing as a log without a base. If you see log with no base written, it is understood base 10. So, number 11 here, evaluate log 100. What that really means is log base 10 of 100. And we could do this now a couple of different ways. We could do it like we did page 1, but I'm not going to. I want to do what we just looked at the top of this page with our properties. Another way of saying 100 would be 10 squared. And then now I have an exponential within a logarithm. They both have a base of 10, so my answer is just simply 2. But yes, you could have simply set it equal to x and solved it like we did on page 1. That would have worked as well. Page 3. Natural logarithms. Okay, we've already looked at the natural base e a few lessons ago. Okay, and E is approximately what? Okay, 2.7. Now, it is also a very typical logarithm to use, so it also kind of has a little bit of a shortcut, if you will. Now, this up here, that is ln x. That's not a 1, it's an L. Okay, ln, log of the natural number of x. It means, if you see that, it means log base e. Now, when we pronounce it, we say the natural log, but it is written ln for log of the natural base. So, looking at this next problem, 12, ln of e, so the natural log of e means log base e of e, which is simply 1 from our properties before. All right, then we have a few calculator problems. Whatever calculator you have, if it's a scientific calculator, will do common logs and natural logs. So our first one here is log 100. You just have to find it on your calculator. Okay, for this calculator, it's right down here in blue, so I've got to hit Control here, and it'll type in log, and for most calculators, it's not going to give you a choice to choose a base. I just simply will come over here and type in the 100, and when I press Enter, the calculator automatically puts the base 10. Again, that is your common log. If there is no base, it's understood base 10. And we get an answer of 2, just like we already verified on example number 11. Now that was a nice, neat answer. Okay, but if you look at 13b, it says, I'm going back to this here, 13b, log 8. So this time, it's not a nice, neat whole number answer. That's why we need the calculator's help. So the nice, neat stuff we can do on our own, but problems like this one, we will need some assistance with the calculator. All right, now part C, the natural log of e. Okay, it's down here, and notice exponentials and logarithms are inverses of each other. You will usually find the buttons connected, just as they are here. So we have the natural base e raised to an exponent of x, but then ln right there above it, so I need to do Control here, ln, and under pi, here's where my e was. And natural log of e is 1, just as we verified on example number 12. And then 13d, the natural log of 0.3. And we get, again, a decimal answer. But all calculators that are scientific calculators will have your common logs and your natural logs as options to choose. All right, and we got one last thing to do, and that's the inverses. So, find the inverse of the function. Again, how do you find an inverse? Switch x and y. So we have x equals 6 to the power of y. And then I want to solve for y. Well, when you are stuck in one form, you change it to the other form. Right now we are stuck in exponential form, so we're going to change it to logarithmic form. Alright, when I do that, the base of my exponential will be the base of my logarithm. What the exponential equals is the argument, and the exponent is what my logarithm equals. And that's basically the answer, except just as before, when we work with inverses, don't ever leave that as y. We want to change it to the inverse notation. So our inverse is log base 6 of x. That would be our answer to this problem. Alright, now for the last one, y equals the natural log of x plus 3. To find the inverse, switch x and y. And now we're stuck, because you cannot multiply this. This is not the distributive property. The whole y plus 3 is the argument to your natural log. So now we're stuck. Let's change it to an exponential. Well, natural log means log of base e. So this would become, the base of your log becomes the base of your exponential. What the logarithm equals is the exponent. And then now this will equal the argument. Not quite solved for y yet. Go one still further there. Subtract 3. And that is basically the answer. But again, we do want to use your inverse notation. And that is your intro lesson into logarithms. Okay, a lot of stuff on this lesson though.